Hey guys, it's Mr. Dave with the Ray Kitty Creation Workshop, and you're here with us again on the Ray Kitty Science Project. I'm excited for some of this science we have today, and we've got some stuff that you can do at home and some stuff that I'd rather you didn't do at home. So first off, kind of for the things that you can do at home, if you want to run and get some supplies, these are some very simple things. I wanted some stuff that you can do with things that you probably already have at home. One of them is going to be a penny. Yeah, a little bitty penny. Okay, so you'll want to find some pennies. You've probably got some laying around. I know we don't use these too often nowadays, but it's just a little penny, 1 cent. Okay, so you will be using a penny. You'll be using some salt. This is plain salt, right? Your regular old salt that you get from wherever. You've probably got some in the cabinet, so grab some salt. If you have that fancy Himalayan, like pink salt and those kind of things, it'll work too. It'll just look a little bit cool. No, I'm kidding. Use cheap salt because you don't want to use the expensive, wonderfully flavored salt. You just want some regular old salt. The next thing you will be using is some vinegar. Okay. Now you want white vinegar. Okay, this is distilled white vinegar. You don't want the apple cider vinegar. It will smell better. Your hands will smell better, but it's not what you want for this one. You want cheap white vinegar. Okay, so altogether, the stuff that you guys will be doing at home, you'll be able to do for probably under $2, okay? Now, if you want to take it a little bit further, one of the other kind of extensions we're going to be doing, you'll be using some batteries, okay? There's two different ways you can do it. If you've got these 9 volts here, you can use a 9 volt, or if you've got a battery pack, you can use a battery pack. This one's got some little alligator clips for leads, so you can use either or, okay? So whatever you've got for a battery, a 9 volt I usually prefer because it's just a little bit easier to, work with and those kind of things. So a 9 volt battery, if you want to take it a little bit further. If you want to, you're like, hey, I'm going to go to the hardware store for this one. I've got some big old galvanized nails, okay? Now, you don't need these huge galvanized nails. These I use for some stucco. These are massive. You don't need these guys. Just a small nail, but it will say galvanized, okay? And that's very important with what we're doing. So you'll need some galvanized nails, okay? Or they may say zinc coated, which zinc coated means it's galvanized. So those ones are kind of the optional if you have them lying around or if you want to go to the store later. But the ones that really to kind of you can do it at home, just some salt, vinegar, and pennies, okay? Because that's a very easy one. And we're going to be doing that at-home one in just a second. But before we do, I'm going to start one of my larger projects going because I want you to kind of see how I get it going. And that one is going to be with a penny. And this one is not something you're going to do at home, okay? So this is not one to do at home. This does involve hydrochloric acid. Okay, this is hydrochloric acid, 31.4%, so this is muriatic acid levels, but this is hydrochloric acid. This is not something you're going to want to play with at home. If you watch Breaking Bad, the tub wouldn't have fallen. But anyway, so this is hydrochloric acid. Now you'll notice that I've got it over here. I've got it separate from my other things. I also have it marked, okay? And I have that marked because hydrochloric acid is clear. And I also have water here, and I don't want to end up mixing up my caustic liquids with my regular benign liquids. So I have it marked. I got a big old pink X, so I know when I'm here, it's easy to identify my dangerous chemicals. Okay, so the hydrochloric acid is not something you're going to do at home, but this is something I'm going to do just to kind of show you some next level to what's going on with these ones. So I'm going to start with my little bitty container of hydrochloric acid, and I'm going to put it right here, okay? Now, I'm not going to use it just yet, but what I'm going to do is because we are going to be working with these pennies, I've got a nice shiny penny here. Now, pennies are made out of copper. No, yeah, they are electroplated with copper, and we'll kind of show you that process in a little bit. But they actually only have a copper coating around the outside. A penny is actually made of zinc, okay? If you call back just a few seconds, you'll remember that I said those nails are zinc coated, okay? So a penny is made of a zinc body with a copper shell or copper electroplating. Now, I've got these little bitty guys here, okay? These are bolt cutters. This is the only way they'll let me into the studio. No, I'm kidding. So I've got these bolt cutters here, and what we're going to do is we're going to take our penny and we're going to cut our penny, okay? So I'm going to put my penny in these bolt cutters. I'll have it right up here, and we're actually going to cut our penny into a little bitty strip, okay? Now, when you're doing this, the copper and zinc are very soft, so you're not going to have anything shooting across the room. But I've got my 2 pieces now, okay? And then I'm going to cut another piece. I'll show you these pieces in just a second, and I'll show you what I'm doing with this. Now, you can sometimes cut these pennies with some tin snips if you're a lot more agile than I am, but bolt cutters are an easy way to do it. So I pinch it in the bolt cutters there. And then I will take my penny out. I'm going to put my bolt cutters back to the side. And the part we're going to use is this little bitty center piece. Okay? This little bitty strip. Now, if you look, you can see on that penny, it's not copper all the way through. Okay? You can see how the inside there is actually like a silvery looking metal. It is zinc. Okay? And that zinc is what the penny's actually made of. It's not made of copper. Now, if you go back certain years, they were all copper. Sometimes they were steel. But our current pennies that we use are really mostly zinc. Okay? Now, that's important because I'm going to take this little bitty strip, okay? And I'm going to take it and I am going to put it in our hydrochloric acid, okay? I'm going to put it in my small beaker of hydrochloric acid, and then we're just going to kind of move it to the side while we do our other ones because we want this to have some time to work, okay? So I'm going to put our penny in this hydrochloric acid. Remember, I marked my acids so I know where my dangerous ones are. And I'm going to be careful not to touch it. I'm just going to drop it in. It's not going to splash or anything. I'm going to put it in there, and you will notice it starts to bubble right away. Okay? Now, we have 2 different metals at play, and this is going to show you something pretty fun about those levels and about our reactivity scale. Okay? As kind of a heads up, our copper is at a different place on our reactivity scale than our zinc. And so they are going to act a little bit different. So I've got that one started there. I'm just going to slide this one way out so I don't bump into it. I've got my other little one here. This one is also marked with an X. This is our hydrochloric acid also. And what I'm going to put in this one here is aluminum foil. Okay? So I'm going to put some aluminum foil into this other hydrochloric acid. Now, you'll notice when I'm using this hydrochloric acid, I'm not getting my head right up above it. There is a vapor there. So you want to make sure, like I said, this is not something you'll do at home, but if you are, someone who's got some experience using these types of materials, make sure that that kind of stays away from where you are. You don't want to be breathing those vapors. So I'm going to take this aluminum foil and I'm going to tear it into a little strip here. I'm going to fold it and I'm going to hang it over my other little cup here of our hydrochloric acid, and I'm going to scooch that one to the side also. So those are going to be over here, out of the way, so I don't bump them and I don't hit those or anything like that. So those are going to be doing what they're doing. Our penny, you saw all those bubbles out of it. Our aluminum foil, you see a very little bit of a reaction there also. You see it kind of bubbling up also. So we're going to come back now to our pennies. Now, first off, I have these nice little sections of pennies that I had cut off. Okay, we're going to use those for references later, but we're going to be working with these 2 pennies right here. And this is the one with the at-home stuff that you guys can do, okay? Now, I want you to kind of look at these pennies and notice that these are some dirty pennies, okay? Copper will oxidize, okay? And when it oxidizes, it gets to be this brown color. Okay, now you say, okay, well, what about the Statue of Liberty? I'm glad you asked, okay? What about the Statue of Liberty? Is it this color here? No, it's copper, but it's green, right? Now, if you look over here, You'll see that I've got some pennies also. These are some quarters. I'll show you a little bit what's up with those in a little bit. But this one here, you'll see that nice green color, that patina, okay? That's called a patina. And that green color is a different stage in that oxidation, okay? So the oxidation will go through different stages, and we'll show you kind of a little bit more of that as we go. So we're going to start with these little guys here. These are just dirty from being in people's hands and people's pockets and all of the dirty places that money goes. So what we're going to do is a very simple one that you can do at home. I like this one because you can do this one even with little bitty guys, and you can show them some fun science as long as they're old enough to know not to put this in their mouth, okay? So there's some high science here for the olders, and there is some easy fun science for the little guys. So what we're going to do is I'm going to get my smaller beaker here, and we're going to create an electrolyte solution, and we're going to do that with our salt, okay? The stoichiometry, if you remember, I always use stoichiometry. The stoichiometry is not very important here, meaning put some salt, put some vinegar, okay? You don't have to be precise about your measurements. I like to put about that much salt, okay? And so if you're doing this at home in a cup, if you don't have these fancy beakers, if you're doing it at home in a cup, you can just pour some salt to where you cover the bottom of the cup. You want it to be pretty saturated, okay? So you want your solution to be pretty salty. This is our vinegar, okay? And we are going to put our vinegar in here. So we're putting our vinegar in with our salt. We don't want to put too awful much. We don't want a huge solution there, okay? So our salt will dissolve to a certain point in our vinegar, okay? Now, this, if you get this on you, you will smell like a pickle. We've done some vinegar ones before, but it's not dangerous, even though this is also an acid, okay? Just like our acid over there, this is acetic acid, but it is just not a very strong acid, so you don't have to worry about getting this on you. It's just vinegar, okay? So what we have here are our pennies. We have our dirty little pennies. Now, I'm going to take one. These two are pretty comparable in their yuckiness, okay? So I'm going to take this penny here, and I will show you there. I'm going to put it into our salt and vinegar solution, okay? Now, it's fun, like I say, if you've got little guys, if you're showing them just the fun of it, this is a fun one, but if for the older guys, we'll talk about the science. So we're going to put this penny in here, and you're going to notice almost right away that penny gets a lot shinier, okay? We've had it in there for maybe 7-8 seconds, okay? And that penny is already a lot shinier. Now, I'm going to get my penny out of there, and I'm going to do that by pouring my solution into this one so my hands don't get too pickly. And I'm going to pour our penny out onto here. And if you look at our two pennies, they were pretty comparable before, but you'll notice there's a pretty large difference here. So what happened is that acetic acid, while it can't quite eat the copper, it can separate the copper sulfate, okay? Copper sulfate is very important. We're going to talk more about copper sulfate in a minute. But it will remove that copper sulfate, and our penny here is a lot shinier than our previous penny because that copper sulfate has now been removed. It's into that acid, okay, or into that acetic acid. So we have this here. What's fun about this, if you are doing this one at home, okay, now we don't want to take a whole lot of time, so I kind of fast forwarded this one for you. If you leave that vinegar on there, okay, if you leave the vinegar and the salt solution on there without rinsing it off, it will actually begin to corrode and begin to darken like that Statue of Liberty, and will end up going into our copper 2, copper 3 from that because that vinegar actually does create or generate all of that little copper sulfate on there. So as it dries and oxidizes, when the oxygen comes in, it really makes it vulnerable to that oxygen, and we will end up getting a nice little rusty patina penny. Now, you can do it over and over again. And what's fun about this one is if you're using that same solution, okay, don't make a new solution. Use this same solution, and the more times you do it, I've got some pennies here. These pennies I've used for, well, there's some cut-up pennies in there, so you know I've done this for this demonstration before. But these pennies have been used over and over and over again. And so now we have all different levels of our copper corrosion on there. And then we can get to this nice green patina. So these ones here, if you allow those pennies to set, air out, oxidize, and then you take those pennies and you put them right back in your solution, okay? Let them clean that off, and then let them oxidize, let them clean it off, let them oxidize. I want you to think about what's happening there. This solution is cleaning those pennies, okay? So this solution is removing that copper sulfate. That nice blue patina is being removed by that vinegar solution. So if it's removing it, where is it going? I'm glad you asked. It is actually going into this solution. Now, if you do this over and over and over again, you're going to end up with something like this. Okay? This right here is a copper sulfate solution. You can see when I put it on the white plate here for contrast, you can see that it's got that nice green color, the exact color of the Statue of Liberty, right? So we've got a lot of that copper sulfate in here. Now, do that with those pennies. Like I say, put them in, take them out, put them in, leave them in overnight, take them out whenever you think about it, and keep doing that until you get some of this copper sulfate, because it's a lot more fun than just blue liquid. I'm going to show you something you can do with this copper sulfate. Okay? Now I've got a quarter. Okay? These are regular old quarters. Everybody, well, this one's not a regular quarter. I already did it to that one. Don't peek at that one. Okay. These are some quarters. Quarters have got that nice, that metal on the outside. They're also copper on the inside. But we're going to be working with that outside on these quarters. And with this copper sulfate, you can do something called electroplating. Okay? And what that means is we're going to take this shiny silver-looking quarter and we are going to coat it chemically with copper. Okay? We're not going to paint it. We are going to electroplate it. Remember how I told you that pennies are not actually all copper, they're electroplated. If you were to continue doing this, we're not going to get to that full shiny, but we are going to have some of that copper on here. So, what you're going to do to electroplate, this is if you want to take it to that next level, okay? This does require your battery. And I've got my alligator clips here, okay? And let's get a penny. I need a penny. I'm going to use this one, okay? So you're going to need a penny. You're going to need a quarter or whatever you want to electroplate. This is kind of fun because if you've got other little metal things that you want to electroplate, you can have a lot of fun with this electroplating, doing all different things. So what we're going to do is I am going to put my lead on my quarter. Okay, I'm going to switch it first. We will be alternating our current, but I'm going to put it on my quarter first, and I'm going to put it on my penny. Okay, so I'll have one on the penny, one on the quarter. Okay, now I am going to clip these onto where my penny is now on my positive, and my quarter is now on my negative. Okay, now this is a direct current, but we're going to be switching the current. So don't get confused with alternating current. This is a direct current, but we will be switching the current later. So what I'm going to do is I'm going to take these two guys here, and I am going to dip them in our solution. Now before I do, I'm going to want a little bit more, so I'm going to add a little bit of vinegar to our solution. Just to get it a little bit deeper. Now you don't want it too deep because you don't want your little alligator clips to get into your solution because they're also electroplated and they will give off that electroplate very quickly. So we want the copper instead. So I'm going to get these guys here and I'm going to dip them into my solution. And when I do, now from where you are, you may not be able to see too much of a reaction, but I'll pull them out and I'll show you what's going on. One thing you want to make sure is that they are not touching each other, because then our current doesn't go through our solution. But what we have here is our quarter and our penny in our solution, okay? And we are running an electrical current through them, and they're going through that solution. If you look closely, you'll see a little bit of bubbles, but that's not really too important for now, because I'm going to go ahead and pull one of them out, and you'll see something's already happening to our quarter here. Now, if we look at our quarter, and we wipe it off a little bit, you may notice on that quarter, this top half is nice and silvery, but look at that bottom half. We actually have the copper from that penny and from our copper sulfate coating and electroplating this quarter. So we have a chemical reaction that is the little bitty atoms from that penny are moving over to this quarter here and electroplating our quarter. Okay, so we've got this side of the quarter, just that part that I dunked in there, you'll see is already that nice pretty copper color. Okay, so if you look up close, you'll see, especially toward that like line on the edge, we've got that like bright new copper. And then down here we have that more, a little bit dirtier, more corroded copper. You say, so what happened to my penny? Now our penny, you may see, if you look, you can see where those little atoms have been stolen. As the electrons are moving, they end up removing these atoms here and then depositing them onto our quarter. Okay? Now, if you want to make this solution a little bit faster, what you can do is just get 2 pennies. Okay? Have your same solution there, salt and vinegar. Okay? And then just dip 2 pennies in there. Now, when you put the 2 pennies in there, you are going to, off of that negative side, you're going to see those bubbles bubbling up in there. And your pennies are going to create a stronger concentration of that copper sulfate. Okay? So this isn't just a green water in here. This is actually copper, little bitty copper atoms that are in that water. Now, what if we were to instead of using copper, what if we did kind of that same process with another type of metal? Okay. Now I have these these big old nails that I showed you. Okay, these are my my zinc coated or galvanized nails, and I'm going to move this one into here for now, because boy, once you make that copper sulfate, you're going to want to keep that. We're going to put some of our vinegar in here. Let's go in the bigger one. We're going to put some of our vinegar in here and a little bit of salt. So this is our electrolyte solution. This is a fun one that you can do. This is very easy. You don't need these. If you look in your garage or wherever, you'll probably have some nails that have got this coating. They're usually the nails that you'll use for things outside because that zinc does not dissolve or it doesn't corrode very quickly. So these nails here, I'm going to put them in our solution. Okay. Now you'll notice not too much is happening, but remember that electricity. When we add our electricity, our positive and our negative side, let's see. I'm going to add that current to our nails here, and you're going to see something start to happen again on that negative side. The same thing is happening here in our container. Let me turn it, that one little label is right in the way. There you go. So let me turn it, there you go. So you can see that our zinc is very reactant to this little electrolysis, well, it is electrolysis, but our electroplating. So that zinc, while it's in there, is showing quite a bit of corrosion, right? It is those atoms are leaving and then entering into our water supply or our vinegar. And so now if we clean these guys off here, you can see that level that zinc has been removed and put into here, and we can get down to the iron. Okay, so these are some fun things you can do with some very safe, easy to use things that you've probably got around the house. Now this one here is electroplating that we did with the batteries, but I want to know what's happening with my hydrochloric acid over there. So I'm going to move these out of the way. Again, the hydrochloric acid is not something that you want to do at home. Make sure that someone who knows how to use those types of materials and is experienced with those type of materials, make sure that they are taking safety precautions. I'm not doing a lot of movement with them here, so I'm just going to slide them over because I know what I've got here. This is my hydrochloric acid. Now, if you look here, where our foil was dipped into the hydrochloric acid, it's gone now. Yeah, it ate that foil or dissolved that foil completely, okay? And that is because this is more reactant than our hydrochloric acid. This acid is strong enough to eat our aluminum foil, but it doesn't mess with the plastic, okay? You say, well, metal's way stronger than plastic. It is, but it depends on where it's at on the reactant scale. This is more reactant than our hydrogen, and so when we put it in there, you can see it really starts to bubble up and it dissolves very quickly. Okay, that vapor there, this is also an exothermic reaction, so this is going to warm up. This is giving you that nice little dark color. So, what about our penny? Okay, let's check out our penny. Now you'll notice our penny stopped bubbling like crazy. Okay, if you look real closely at this penny, it's no longer bubbling. It's just floating at the top. Now, if you remember, that penny sunk when we first put it in there, but now it's floating. Okay, so what we want to do is we want to get that penny out of there, and we're going to get the penny out, and we are going to kind of see what happened. Now, before I mess with this penny, I'm going to make sure that I will dilute that acid, so I'm not touching that acid, okay? So I've got our acid here. I'm going to put it right over here. And I am going to take our little penny, and I'm going to pour some water in here, okay, to dilute that acid to where it's not going to be dangerous to touch, okay? So I've diluted that. Another fun little thing just to make sure that it is no longer reactant, acid and a base, just like we've done before. There you go. We have neutralized that acid. We've got our penny here. Now, it looks like it worked perfectly. If you remember, we cut a strip of penny, and I had, where did I put, there we go. Let me grab the other little pennies here. So before, I had our pennies, and you could see inside of that penny was that nice, shiny, silvery zinc, right? Now, the zinc is more reactive than the copper. The copper wasn't even affected by the hydrochloric acid, that acid that just destroyed that aluminum foil. The copper is still here. But if you look, let me see if I can very carefully, open this up. You can, there we go. There's a little strip of it. You can actually open this little penny up and see inside of it, if I can get it. Get something to open this up with. There we go. And you can actually see inside of that penny, it is now just a little hollow copper shell. That penny is completely hollow. We've eaten all of that or dissolved all of that zinc out of the inside, and now we just have a hollow copper shell. So the copper was not as reactive, so it was okay in that acid, but our zinc was very reactive, and that's why if we put this little zinc nail into our acid, we see that big reaction going on there. Okay. So the zinc is very reactive, but the copper is not as reactive. Okay, so today we talked about our acids. We have our acetic acid, which was our vinegar here. Okay, this is a nice weak acid. You can use it to clean those pennies up, and those pennies will look great. You remember that nice shiny penny that we took out of there? Remember how I said if you leave the vinegar on there? Well, this is what happens if you leave the vinegar on there. That nice shiny penny has already begun to be covered with that corrosion. All right, well, thank you guys, and remember, science shows you matter. I'm Mr. Dave with the Ray Kitty Science Project.